All right, great. Hey, somebody asked me at lunch about the NASA hat. I've been wearing a NASA hat for the last 25 GPSLs. And my hope was that it eventually would, through osmosis, get me a job at NASA, right? Well, after 25 years of wearing this hat, it finally did. Because my friend said, hey, Bill, there's an opening at NASA, and there rarely is. Come and interview. So I did. That was 5 years ago. I was currently working at the Patriot Missile for the Army Missile Command. And so I went to the interview, and they said, now, Bill, you're kind of close to retirement age. We need somebody here for the Artemis Moon Rocket program for 5 years. How long do you plan to work? I said, I plan to retire on Mars, and working here is the way to make that happen. And I think that's why they hired me. But I just completed 5 years there, and I retired almost a year ago now. So, but to find that this is the real NASA hat now. So we're going to talk about some of the programs at the University of Alabama, Huntsville. They have this amazing group called the Space Hardware Club. And they have a group of over 100 students from all different disciplines. You could be a biology or a management or business major. You don't have to be a hardcore computer science or engineering major to join this group. And so they do formal mission planning. They do trade studies when they're doing their proposals for their different payloads. And so they work on coordinating the flight profile and mission planning, and they actually have critical design reviews. So it's all done very formally, and they get a lot of experience for their future work. Well, there you go. They have 5 different programs that they do. BalloonSat, it's kind of, they launch these things and they kind of parachute down, and they're like little drop canisters they drop from balloons. We have a BalloonSat program. Currently there are 4 different projects: Havoc, Luma, Pascal, and S-Park. And then they have a rocketry program and a space flight where they're actually working on sending a CubeSat into space. And they do a lot of outreach programs to the local middle schools and high schools, and including doing several BalloonSat flights with student payloads in the surrounding communities. So this is the AutoSat program. And it's basically, they're sending up rockets, and they're trying to, once it lands or it goes up, a rover parachutes it out, lands, and it has to make a certain goal. And it's a really cool program. You can see one of the rovers there that pops out of these rockets. They have this Astra. They're building a Mars simulation rover, and they're actually doing competitions in Utah. In fact, many of the students are there right now. And so they have to design these robots they're basically designing Mars robots. They don't have to go to Mars so to compete. CanSat, now this is pretty cool. Also, once again, they send up a little model rocket, and it pops out a payload, and these payloads are recovered. You can see an example of one on the bottom right-hand corner here. But like I say, they hold weekly meetings, board meetings. They discuss the new projects. They get funding from different organizations and private donations, and they have quite a program going. And if you have an interest in meteorology, they have the Severe Weather Institute right next door. And a lot of the students participate in operating that. They go out and they chase storms with these radar trucks that you see like in the movie Twister. And these are for real. And they actually launched a high-altitude balloon in the eye wall of a hurricane in New Orleans. And they inflated the balloon inside of their van. And they had the radios on outside. And I saw the video. They pulled it out. They had an APRS tracker on it. And they launched that balloon in an 80-mile-an-hour wind in the hurricane. And it went, choo! It went about a mile in a few seconds. And I saw the APRS reading. It said 80. And it was 200 feet above the ground. I've never seen anything quite like this. It's probably one of the highest wind launches I've ever seen for a high-altitude balloon. They're working on this really cool subsonic automated plane. It's called Sparrow. And they're working on their first working prototype. They're actually doing a competition, and they're manufacturing the wings of the aircraft and looking to do a wire cutting table to improve their abilities, but they're actually working on all these kind of little drone projects too. This is the BalloonSat program, and you can see some of the many flights that they've been doing here. They have a dedicated launch team, and they all go out. Sometimes they go out a day or two later to recover these. In fact, one of them's still out there in a tree. They're trying to figure out how to climb the mountain and get up to it. But this is called the Space Harbor Club BalloonSat program. And in fact, one of them we did from Antarctica. I showed you those slides last year. So that's what it's like down the bottom to launch a balloon in Antarctica. You don't have to worry about trees, but it is a little bit cold. That was the warmest day of the year we launched there, and it was 28 degrees.
Above zero?
Yes, yes. This is the Havoc payload. I'll talk a little bit about that. It's called High Altitude Visual Orientation Control. The Havoc project has the goal of developing and researching hardware capable of stabilizing its direction and rotational velocity within the stratosphere. And they want to enable that for stable video. How many of you attended GPSL 2 years ago in Huntsville? They actually showed this payload operating. They would spin it and it would immediately snap back into place. And it's really, really a cool system. And under normal flight conditions, they were able to achieve a less than 10 degree orientation error and less than 7 degrees per second velocity error through the use of pressurized nitrogen pneumatic system and convergent to divergent nozzles. If you remember the Gemini moon, when they did spacewalk and they had the little air jet control, it's handled in kind of a similar manner. And it's, it really works pretty well. Now this is one that they're currently working on, and how many of you have launched a balloon that came down in a 1,000-acre field and there's one tree in the middle of it, and it lands on the top of that tree? Wouldn't it be great to avoid that tree? Or the mountain? Or a lake? Or someplace that's pretty hazardous? Like one place I landed in was a swamp in South Carolina. Before I walked in there, they said, you know, before you go in there, I want to warn you, it's filled with alligators. My payload's still in there. So I did not go after that one. And we had one balloon land in Texas that I was riding along with, and It was way up in a tree in a private hunting preserve. And had we had an ability to steer it, we could have avoided that preserve. But instead, we had some discussion, well, it's right on the edge, let's go get it. I think we should probably ask permission first. Well, the guy came in his utility vehicle, had a big shotgun rifle in the back, says, I can get that down for you. And we went out there in his utility vehicle, pointed that rifle, and in one shot, the payload string was 100 feet high. He was able to sever that line with the first shot, and everything came down. So it was a very good thing we asked permission first. So Luma is a combination of a balloon cut down and helium venting system. And so I've donated some money to their program because I want them to add to it a little feature. And that feature is, let's say you send your balloon up, you vent it, you come down at a slow control rate, or you vent enough, it'll come down with the balloon still intact. Gets down to within a couple hundred feet of the ground, and you want it to come towards you, towards a nice landing spot instead of where it's heading. I was going to put a ducted fan system to vertically compensate the difference and have it neutrally float. And with some steering fans on the back, and then the whole thing, you could fly it directly to you on the side of the road. So that's going to be one of their add-ons that I've funded for them to work on. So, because that would be really great. You don't have to walk out in the muddy field or cross into the buffalo pasture. You remember the story, the Edge of State Sciences, where we went out, one of our payloads landed in a buffalo ranch. And we were debating, well, it's right out there, but we better contact the rancher. He came out, he was pretty excited. Don't go in there, don't go in there, wait. He came back with a whole bucket full of Coke can-sized buffalo trees. And they were compressed alfalfa or something like that. And he says, the way to do a buffalo's heart is through its stomach. Now, I'm going to go out there and toss these at the buffaloes if they get a little agitated, because if you get them riled up, they'll run over you through my fence and 10 other fences before they even consider slowing down a little bit. So we want to avoid buffalo pastures at all costs. So that's what they're working on. And this is called the Long Range Universal Mission Administrator, or LUMA for short. So they're developing the venting system, a balloon cut-down system, and a long-range communication system for command and control. Okay, this is the Pascal system, and this is atmospheric sampling and chemical analysis. They actually want to sample air samples from and within a multi-cell thunderstorm. For those of you who love storm chasing, this is the project for you, because you get to launch balloons real close and in thunderstorms. And they have a pump, sample bags, solenoids, NO2 sensors, and they can take 6 samples during a flight, and they're going to be analyzed by a ground-based optical spectrometer. So they're looking at the production of different nitrogen, oxygen, nitrous compounds to see what effect a thunderstorm has on the concentration inside the thunderstorm. And gathering data to validate, there's a satellite called Tempo, and it's, they're going to validate the satellite data with payload from inside the storm itself. They're also working on a balloon called Solar Heliotrope Auto Rising Contraption. SHARP for short. That's a great name, huh? They want to improve fabrication procedures for basically solar balloons. How many of you have ever played with a solar balloon or seen them online? Yeah, there's actually, I see a group out in New Mexico that has been flying quite a few of these. And you basically put a bag of carbon, a plastic bag filled with carbon dust, and you can actually get it to lift a payload, probably upwards of 2 ounces or more, depending on the size of the balloon. They'll go up to about 60,000 feet and stay there all day and come down at night. No helium, just hot air. You just lay the bag out, if it's big enough, and when the sun gets up high enough, off it goes with your payload. So they're going to be collecting stuff to figure out how to do this. And there's a pretty good size of one that they've got there on the bottom right. So you can get an all-day flight without any lifting gas at all. So we're working on different materials for that. Years ago at one of the Great Plains Super Lunch, we had Robert Rocky, and he showed how to make one of these. He called them sky diamonds.
Tetroons or something?
And they were tetroons made out of tape. He would take the sides and he would fill them with carbon black. And he had quite a few flights he did from up in Detroit. They also have a rocketry program, and they do a number of competitions with this and with a number of goals. So you can see there's all kinds of stuff they've been doing, and they actually get their amateur rocket certification through this program. And they're working on making different composite materials for rocket bodies, fin assemblies, and the motor mounting tubes. So they're learning how to do composites as well. And there is a rocketry news project. It's called Elysium. I mean, the Spaceport American Cup, but their project's called Elysium. And they have to build a rocket that will go to 10,000 feet. But I believe you cannot go over 10,000 feet. So they said you had to get as close to it, but not over. And they're working on a liquid rocket engine project as well. So it's a very ambitious group. So any questions on activities of the Space Harbor Club? Yes, Jim.
I'm sorry, I maybe missed it, but how do they finance?
Space grant, NASA space grant, and private funding. Doesn't matter. Did you? Oh, okay. Is that?
On the solar balloons, is there any validity to doing like a hybrid where you have enough gas to kind of keep you aloft? Does that have any advantages?
That's a good question. That might be a really interesting way to do it. Just be neutrally buoyant and allow on the
something like that.
yeah. So typically these are not sealed off; they're not super pressure. Now, what I have heard is that if you use this pure black trash bag material, when it gets up to 60,000 feet, it actually melts the material. There's that much heat it collects. So it's better to have polyethylene, high quality like broadcloth, with carbon black on the inside. That works a little better. But there's all kinds of people flying these. Just a tube of trash bags, big leaf bags taped together will take off. And actually carry enough to carry a small payload. With that, I'm going to go to the next talk.
Yeah, you can just escape out of that, and the other one I think is already loaded.
Okay.
Let me have one more question.
Yeah.
Hey Bill, what is carbon black and where can I buy it?
I'll switch.
I'm not sure where to buy it, but it's called, it's maybe a paint store. But it's lamp black or carbon black. It's real fine carbon powder. And they probably use it for different paints.
Is this?
That's it.
That's fine.
Okay, well, let's go a little more detail in the long-range universal mission administrator. And you see they've got a big student team, and it's the BalloonSat team is developing this. So I'll go into, they've got a number of programs that they've been doing. They've done a lot of research, and they were participating in the National Eclipse Ballooning Project. How many of you all were involved in the eclipse balloons? Okay, we got a few there. Now, they've done a number of projects for drop halo, and the Helen is a high energy lightning emissions deal. And they were doing a project where they were trying to get a balloon to float at a particular altitude, and it was automatically taking off. They'd have it sit there, and it would just drop ballast until it took off. And then it would level off a few hundred feet up or a few thousand feet up. So the first flight test I witnessed of that, it went up, and it was supposed to go and float at 5,000 feet. Instead, it floated at 100 feet. And so now it's going along, floating 100 feet above the ground. They're trying to jump up and grab it because sometimes it got within 30 feet of the ground. And it went over a residential neighborhood of Huntsville for about an hour, just rooftop to rooftop, bouncing off of roofs. Never got caught in a tree. And they were driving along, and finally hit a tree and came down. But they had a little error in their altitude algorithm. Oops, I hit the wrong button there. Let me get it back. How do I get this back?
Hit F5 on the keyboard.
Oh, yeah. There we go. So typically, you got your typical balloon flight. They rise at a constant rate, hit burst point, parachute comes out, and down you go. So with a manually controlled vent, and it's got a little bit of vented latency, your profile is what you would see on the right. So they were testing it by venting until they start coming down, and then after a certain point, they hit a cut down to come down in a normal manner. And it does affect where you're going to land, so you can actually choose your landing site by doing this method. You can control the landing zone with some degree of accuracy. And so in other words, you can have it, instead of just cutting it down and hope for the best, you can give yourself some time, latency time, to choose a good landing spot and have it drift far enough to really improve your chances. So they want to centralize and maintain the design of their communications and their for a full duration of how people are going to fly it. And eventually, like I say, we're going to be bringing down the balloon completely intact with a final adjustment with a vented ducted fan system. So you'll end up with the balloon. I don't know if you could reuse it much after that, but it's possible. So we've got basically the experiment and the cut down system. There's a lot of slides here, so the time allotted, I'm going to skip through some of these. So this is what their plan is, to let it go up normal, float, and then cut down. This is their first smart balloon. This is the one I told you about that actually took itself off. And it was pretty cool to watch because it just sat there venting liquid out of it was alcohol. And so they had a container of alcohol and it just started dropping alcohol until it actually took off. And you could just sit there and watch it, and this balloon actually launched itself. So their first, they used a drop designated release of payload, I like that acronym, and they flew this several times successfully. And they used some XBs. I've actually had on a 915 megahertz, 100 milliwatt XB, I communicated directly to a balloon 20 miles away. It is possible to do with high gain antennas. That's a 915 megahertz system. So they've got this helium outflow unit. It's a vent that was developed as part of the Eclipse ballooning project. It looks complicated, but it actually is pretty robust in how it works. One of the problems you have is getting the lifting gas out in time before the balloon bursts. And when you get up high enough, if you get it too high, it's hard to get the helium gas out. So I think it's right around 26 kilometers. You're really going to have trouble getting enough helium vented to stop the descent. So a lot of these flights, we did these tests at low that altitude. Okay, so here's an example of the payload design. The core serves as the brain of the payload. They have a primary flight control unit which allows for the venting of the balloon, Ciub fence flight termination, and they had the LRC communicates with the ground station to relay flight data and updates to the flight profile. You could actually send a different flight cut down profile directly to it, rather than have it go with the profile that was loaded in the machine. There's an example. You can actually see one of the XB modules that communicate between the modules. The XBs work pretty well for inter-payload communications. But like I said, you can get some pretty serious range on them. So this is another view of the vent drop system. And these, how many of you used the archery release as a drop cut down mechanism? Have anybody used that? It actually works pretty well. That's a standard archery release. And they incorporate that into their cut down mechanism. And there it is. And so the jaws hold on to the top payload, and then we have a servo come down and flip the trigger, and there's not a lot of pressure needed on the trigger, and it'll open those jaws, and it seems pretty reliable. They've had good luck with this. It's worked in both several of their flights that they were testing for this release mechanism.
What operates the servo?
That's commanded by the uplink command from the XBs and the flight computer. Sometimes it's just based on an altitude limit that they reset. Now this is the ventilation system that they're working on. They have open and closed flaps. They used these are a couple of the concepts that they worked on. They had a helical venting arrangement, a flap arrangement, and a plunger arrangement. So these are all the ones you can see. The server On the left there, how that plunger works, the servo opens and closes that valve on the left. I believe this is probably one of the ones that they were looking at because it's relatively simple to implement, but gives you a fair amount of control. And they did this vent trade-off to figure out which one they liked the best. And you can see they scored fairly high on the plunger. They were looking at how sealable they were too. So it looks like the plunger won out of this vent and this trade. See, they do things like this in this club. This is what you can do in industry when you're trading off different designs. And so they really weight everything and figure out which gets the best score. So this is the plunger outfit. Looks like they have a Raspberry Pi Pico in there, controlling a servo, which is then controlled from the uplink commands and the flight computer that's hooked into it. And that, of course, ties into the bottom of the neck of the balloon. And these are the dimensions of that. You can see the servo mechanism. All of this is 3D printed. And then it hooks into the release mechanism with that archery release. And there you go. That's open on the left and closed on the right. And then the release is in the middle. So it's a pretty neat little system that they've developed here. So that just hooks onto your balloon, your flight train comes down, and then you can cut away, or you can bend it until the whole thing comes down. Here's another view of it. And here's a cutaway breakout of how everything assembles. So how many of you got access to a 3D printer? So you can make your own. I'll see if they can offer some STL files for these. This is the separated view. And there you go. Oh, these are some of the masses here. So the vent drop is about a pound, a little over a pound. So your whole thing, the whole thing is about 2 pounds. That's the drop mechanism and the vent valve. And these are some of the microcontrollers they were looking at. Give you an idea of the comparison between the Pi Pico and all these other little smaller computers. They like the Pi Pico 2 the best. It is a very capable board, I have to say. For the prices, you can't beat it. And they did a study of barometer chips and looked at the differences on these. These are some that they looked at. I've flown the 5611s, which do work up to 10 millibars or so. But they're a little trickier to work with. They seem to like the MS56070, the one on the left there. And they flew thermistors, so they've gone through all these to check out the most accurate methods. They like that thermistor. You can see how they do the trade study on all these. Now, I'm going to have to throw my own in here, that Chinese ATGM336H is my favorite.
So the startup spike's pretty rough.
It is. It does have a very brief, very high, like 200 milliamp. So that's important to have a super cap on the system for just that.
I had to add an extra 47 micro next to it just to absorb it because it was resetting my processor, even with the super cap.
Right. You put a 47 micro cap right next to it?
Yeah.
Okay.
On the 3-volt line.
That's good to know.
And I use it's a ceramic 0806 or whatever.
Right.
And it worked just fine. It basically fit in place of an 01 microfarad.
Sure. That's a good hint. For those that didn't hear Zach, when you're using the ATGM336H GPS, it does have an initial milliseconds, 200 milliamp direct power surge, and he put a 47 mic capacitor across the power lead for that, in addition to the super caps.
Yep.
Okay. This is a comparison with some of the ZP modules and XP modules that they use. And the one I've had good luck with for long range is that XP Pro 900. Because it's got 100 milliwatts on the 915 megahertz band. And that's why, as you can see there, it's got 15 kilometers line of sight range. But it's a little pricier, it's $54. But if you're doing a lot of inter-payload comms, or even want to get some data to put down to the ground, that would be the one to use. But for closer distances on a payload stream, you could use any of these. Of course, they like that one. So they pretty much, let's see, they need 13.8 volts for their comm system. How many of you have been flying the 18650 batteries? Have you had any good luck with those? Anybody flying those? They're rechargeable and they're high power, but I don't know quite how they do in low temperature. I think that's pretty much it. I just wanted to show you some of the block diagrams that they use for their radio. They're using the DRA-818, which is a VHF chip. It's a transceiver chip that's really cool. And the Raspberry Pi Pico to control it. And it's a 2-meter FM module. I've seen people make APRS trackers out of a microcontroller with one of those chips. They're a half watt. And
half or 1 watt.
Either 1 watt or half watt.
That's what I put on the Pico, but I just got done flying.
Oh, okay, cool.
It's the SA18 because it supposedly has like extra half volt of headroom. It can go up to 5 volts instead of 4.5.
Oh, cool. Okay. The SA18.
Yeah. Otherwise, it's exactly the same chip.
Okay. It's the SA18 or 818?
818.
Okay.
There's a V and a U model, VHF and UHF.
All right. And I believe on the CubeSat simulator, they're using an SR105U, and they have an SR105D. It's made by a Chinese company that's similar module.
That might be the inner workings of those modules. I can't
Could be, yeah. Okay, and they like the DRA-818 the best. So anyways, that's a little, there's an actual, oops, I'm getting feedback here. That's the 818V and the Raspberry Pi Pico combinations that they're using for their data transmission. And that is a pretty, Any other hens or kinks for using that SA818?
You need to put output filtering on it because it doesn't comply otherwise. Otherwise, it just kind of works. They're easy to hand solder, relatively easy.
Yeah. And they're cheap,
Yeah, $12, $8, somewhere in there.
about $12 a piece. Okay. So you have a little, between that combination, you've got a little cheap Gatorade. Okay, well, I'm gonna quit at this point, and any questions about what they're planning to do with their drop and release and vent mechanism? Thank you. All right, I'll turn it back to you.
Bill?